Okay, we want to add two rational functions. Now, these are about the simplest type of rational functions you can have, but if you understand the principle here, I'm going to subtract. Give myself another chance to mess up, okay? Okay, so we want to do this. Well, just like with fractions, you have to have the same denominator in order to add the things. Okay, so in order to get the same denominator, well, a common denominator would be x minus 3 times x plus 4. So if I multiply this by x plus 4 over x plus 4, then the denominator is going to be x minus 3 times x plus 4, right? And the value of the expression isn't going to change because whatever x is, x plus 4 over x plus 4 is going to be 1, right? If x is 700, then you get 704 over 704. If x is negative 368, then x plus 4 is negative 364, and x plus 4 is negative 364, and negative 364 over negative 364 is still 1, then you can understand that this is always going to be 1. And multiplying by 1 doesn't make any difference. And if we multiply this by x plus 3 over x plus 3, which we can certainly do without changing its value for the same reason, this is 1, then you have x plus 4 times x plus 3 in the denominator, and it should have been x minus 3, shouldn't it? Okay, that's going to give us the same denominator. It would have been perfectly okay to multiply by x plus 3 over x plus 3, but it wouldn't have been helpful. Wouldn't have changed the truth. It wouldn't have changed the value of the expression, but this is what we've got to do. Okay, so now we've got x plus 5 times x plus 4 minus the quantity x minus 7 times x minus 3, all divided by x minus 3 times x plus 4. Now we can multiply these out. Again, you want to use a distributive law to be sure you're doing them right. I'm not using the distributive law, so I'm probably messing them up. Okay, so what we have, then minus the quantity x squared minus 10x plus 21. Okay. So, expanding this, we get this. Expanding this, we get this, if I've done it right. And we could expand the denominator, but we usually don't want to just yet. You'll see why. Okay, so now the x squareds add up to 0, right? Probably ought to go ahead and do this stuff. I've got room, so let's go ahead and do it. And I definitely recommend that you do this step to be sure that you have the signs right. Distributing the negative through this expression. If you try to do it all in your head, you've got a 60% chance of messing one of the signs up, okay? Depending on how careful you are. I know I'd have a good chance of doing it. Okay? And now x squared minus x squared is 0. 9x plus 10x is 19x. 20 and minus 21 is negative 1. And there we have the result in factored form. Okay? This is factored form. And this is expanded form. Factored form is what you use when you want to see what's going on. Expanded form is what you use when you want to confuse yourself or somebody else. Or answer a question that asks for the expanded form. Okay, sometimes it's an important form. Usually you want to see it factored, as that tells you just exactly what the expression is made up of. Okay, let's see now. Okay, now we have another one. It's a little longer, but really no harder. I think we just keep track of what we're doing. Something very much like this. Everybody had the x squared plus 11x plus 30. You had different numbers. Okay. And I did this because it's the way this factors, it's likely that one of these factors will match one of these factors, okay? Now let me do this. Oh, never mind. I'll keep it this way. Okay. And if they don't match, then it still works. Okay, so what we want to do is we want to factor the denominator here, if possible. Now, if you see a quadratic in the denominator, this had been x squared plus 12x plus 30, I wouldn't have been able to factor it. Then you'd have been just stuck. Okay? Then maybe we'll do that just to see how it works out. Yeah, the 12x there instead of 11x. Okay, but continuing with what we have here, we see now that this is x plus 5. Now, what else do we need in the denominator here so that we're going to have everything we need from this denominator? Well, we've already got an x plus 6, but we need an x plus 5. So we multiply this by x plus 5 over x plus 5. And then we're going to do x minus 4 over x plus 5 times x plus 6. We have to have the same denominator, which is going to include x minus 3, x plus 6, and x plus 5 at least that much. So what do we have? Well, what do we have in this denominator that we don't have in this one? We have an x minus 3. Okay, so we do an x minus 3 over x minus 3. And now we see that the denominators match. Now I'm just kind of skipping a step here. I'm going to go ahead and multiply x plus 5 by x plus 5. And then the x minus 4 by the x minus 3. And again, I'm going to leave the denominator factored. To have the same denominator as the numerator. So now I get 2x squared plus 3x plus 27, all divided by x minus 3 times x plus 6 times x plus 5. Well, this isn't going to factor. Okay. I've got a plus 27 and a plus here, so whatever two factors I've got here have to add up to 3. Well, there are no two factors of 27 that add up to 3, right? Just isn't going to happen. The smallest sum you could get would be factor this into 3 times 9, and then multiply the 3 by the 2 and stuff like that. It's going to give you a number a lot bigger than 3. You can try all possibilities because that's what you want to do if you're not sure. If you can't do it in your head. And I don't expect everybody to be able to do it in their head. You try all possibilities for factoring this, and you can eliminate all possibilities. There's a shortcut to that using the discriminant and the quadratic formula. But I'm not going to talk about that. Now, if I had this, we're going to find that this can't be factored with over integers, okay? Or rational numbers or irrational numbers. It can be factored. The discriminant is positive, but okay. In order to do this, the denominator has to contain the x minus 3 and the x plus 6. And it's also got to contain x squared plus 12x plus 30. I don't have room to do this, but I'll squeeze it in. Okay. So now I have a denominator that covers this one and this one. Then I'm going to have my x minus 4 over x squared plus 12x plus 30 times what? X minus 3 times x plus 6 over x minus 3 times x plus 6. Well, it gets to be a little messy when you try to expand it. So I'm not going to go through the details of it. We use a distributable. I don't have room on the board. I don't really want to take the time, but I just want to point out that just because you can't factor this doesn't mean you can't find a common denominator. And of course, this will be part of the common denominator. So this equals the sum of the numerators divided by this denominator, x minus 3 times x plus 6 times x squared plus 12x plus 30. Okay. Be a little bit of a pain to expand this because you would have to expand the numerator, then see if you can factor it, which is unlikely, unless I set it up that way. Okay?